All right, our last example, we're going to use linear functions to solve problems. Sounds like fun, and look at this nice little picture we get to use. All right, so a chairlift starts zero point 0.5 miles above the base of a mountain and travels up the mountain at a constant speed. How far from the base of the mountain is the chairlift after 10 minutes? So here's some information in the picture that's helpful. Here is where the chairlift starts, 0.5 miles from the base. And then the chairlift travels 6 miles per hour. It takes 15 minutes to reach the top. So there's the information for the situation. We're going to write a linear function to represent the distance the chairlift travels from the base of the mountain. So we're actually going to use some different variables too. This is going to get really exciting. So we're going to let t equal our time in minutes. The reason why we're going to let t equal our time in minutes is because the question they're asking is how far from the base of the mountain is the chairlift after 10 minutes? So we want our answer in minutes. We do have this nice little thing here. It says check your units. That's going to come into play in just a second here. So, actually it's going to come into play right now. The speed of the chairlift is in miles per hour. So we want to convert the speed to miles per minute. So the speed of the chairlift, here's how we're going to do that conversion, is 6 miles per hour. So that's per 1 hour. We can multiply that by a conversion rate. We know that there are 60 minutes in 1 hour. So we're going to multiply it by 1 hour over 60 minutes. So this is the same value, this fraction. 1 hour is the same thing as 60 minutes. So essentially, it's like a 1 over 1. It doesn't have a value of anything other than 1. So if we multiply our rate of 6 miles per hour times this conversion, what we get to do is 6 times 1 is 6 over 60, but these hour units cancel out and we get miles per minute. So we just converted to miles per minute. Now 6 divided by 60, we'll go ahead and just divide that, and we're getting 0.1 miles per minute. That's how much we're traveling. So we are talking distance. Here's what our equation is going to look like in words. The distance traveled is equal to the rate of the chairlift times our time traveling. That's going to be our number of minutes. Oh, I am running out of time. Plus I'm running out of space. What did I just say? I don't even know. Plus the distance from the base. So writing it out in words just gives us a structure to plug in different values. The distance traveled, so we're going to say our distance traveled after t minutes is equal to the rate of the chairlift. That's what we just figured out. That's the 0.1 times the time traveling is t plus the distance from the base, 0.5. So the distance traveled is the distance after t minutes, so that's just our label there. The rate of the chairlift is 0.1 times the time traveling is t minutes, plus the distance from the base is 0.5. Now to answer the question that they're asking, how far from the base of the mountain is the chairlift after 10 minutes? So they're giving us a time right here. We're going to plug in a 10 for our time. So 0.1 times 10. I totally don't have room, so I hope you guys can follow what I'm doing. Plus 0.5. 0.1 times 10 is 1. Plus 0.5, and we get 1.5. So that 1.5 is the distance traveled. Our distance was in miles. So after 10 minutes, the chairlift will be 1.5 miles. I'm going to put a label on that, up the mountainside. So that is answering that question. Here we have a graph. We could have graphed that. I'm just going to skip over that so we can answer our second question and call this example done. All right, so in this example, how would the function, graph, and equation change if the speed is 4 miles per hour? What is the effect on the domain? So up here we had a rate of 6 miles per hour and we had to convert that. So how that would look with a speed of 4 miles per hour, so it's going slower. This is a slower chairlift. It only covers 4 miles in each hour versus 6 miles in each hour. So we would take 4 miles per hour and we'll convert that with our conversion of 1 hour over 60 minutes. Your hours cancel, leaving us with 4 over 60. This is 4 miles. Now we're in minutes. 4 over 60 reduces to 1 over 15. And that 1 over 15, if you divide that on your calculator, you get a 0.06 repeating. We can't have any repeating decimals. We don't want to round anything. So in this case, we would leave the 1 over 15. So this 0.1 that we got when we converted from miles per minute, that's your rate. We're going to replace with a 1 over 15. So here's how the equation would look different. We would have our distance traveled after t minutes is 1 over 15x. We have the same starting point, so plus 0.5. We're still starting 0.5 miles from the base. So the starting point remains the same. The slope would decrease. We're going slower now. So I didn't graph the one above, but let's say a slope of 0.1. If you're going 6 miles per hour, might look something like this. A slope that if you're only going 4 miles per hour, it's going to be slower. So the slope would be less steep, looking like that. And then how would the domain be affected? The domain would be increased.